All right, this video is to show you how to solve logarithmic equations algebraically. And we have two types of equations. One will be in one video and one will be in the other video. This video is going to cover when we have one logarithm and one or more constants in the equation. You can see an example here, log base 2 of the quantity x plus 3 equals 7. The steps for doing this are: number one, isolate the logarithm on one side of the equation. That means all I should have on one side of the equation is the logarithm. Everything else needs to be on the other side. Once I've completed that, then I'll rewrite the equation in exponential form. As soon as that is done, I will solve that equation. Sometimes it's just as simple as evaluating. And then, of course, like all logarithmic equations, we should always check for extraneous solutions. Let's work a couple of examples to see how this works. So in number one, I have log base 4 of the quantity x minus 8 minus 3 equals 1. I can look at this and I can see that it is not isolated. The logarithm is not isolated because I have a minus 3 after it. So the first thing I would do is add 3 to both sides. So that's going to leave us with log base 4 of x minus 8. And then I would add 3 to both sides, so I'd have 4. And so we simply added 3 to both sides. There we go. Now it is isolated on one side of the equation, so the next step is to rewrite it as an exponential equation. I'm going to just change forms. So in doing that, I'm going to have a base of 4. So we're going to base of 4. The exponent is what the logarithm was equal to, so it's 4 to the 4th power, is equal to x minus 8. So here we rewrote the equation in exponential form. Now, my next step, once I've done that, is to solve the equation. So I can see that I have 4 to the 4th power. If I'm not sure what that is, I can simply go over to my calculator. There it is. We'll do 4 to the 4th power. And we can see that that is equal to 256. So now I'm into the solving process. I evaluated the 4 to the 4th power, and that is equal to x minus 8. So here I just evaluated the exponent. Let's see, evaluate, got an extra t in there. Evaluated the exponent. Now that I've done that, I'm going to finish solving. And in this case, I would just add 8 to both sides. All right, I'm going to add 8 to both sides. So 256 plus 8 will give us 264, I believe. So we'll have that x is equal to 264. If you're not sure, just go to your calculator, 256 plus 8, and it is 264. So we added 8 to both sides. All right. Now my last and final step is I need to go make sure that this actually works in the original equation. I need to check for extraneous solutions. This I always just do on the calculator. So we have a proposed solution of 264. Let's make sure it works back in the original equation. So I'm going to go, not log, sorry, math, because I need a different base in there. Come up to option A, log base, base of 4. And now I'm going to substitute in 264 for x minus 8. And then on the outside of the logarithm, another C in there we go. On the outside of that logarithm, I need minus 3. Now, when I press enter, if it's equal to 1, this is a valid solution. And it is. So that means I would come back to my paper. Excuse me. Back to my paper. And I would just box in 200 and x equals 264. There we go. Let's look at example 2. In this one, I have 10 times the logarithm base 3 of the quantity 6m is equal to 40. Again, this one is not isolated because it has times 10 to it. So that's the first thing I need to do is isolate the logarithm. To do that, I'm just going to divide both sides by 10 because I've got multiplication. Its opposite operation is division. That's going to leave us with log base 3 of the quantity 6m is equal to, and 40 divided by 10 would be 4. So all I've done here is divided both sides by 10. Now it's isolated, so now I'm going to go ahead and rewrite it in exponential form. To do that, my base is 3. The logarithm is equal to 4, so that means my exponent is 4, and this thing is going to be equal to 6m. So again, here all we did was rewrote the equation in exponential form. And so now what we're going to do is we're going to look at solving it. All right, we're going to look at solving it. So to solve this thing, what I'm going to need to do is, number one, evaluate 3 to the 4th. So I'm going to come over to my calculator. I got 3 raised to the 4th power. That is 81. So I have 81 is equal to 6m. So evaluated the exponent. Evaluated the exponent. And now I just need to finish solving. So right now I have 6 times m, so the opposite operation here would be division. So that means I'm going to divide 81 by 6. Let's see what, excuse me again, I have a cold. 81 divided by 6 is 13.5, or as a fraction, 27 over 2. So we're going to put that in there. So we've got 27 divided by 2. Let's do m equals. M equals. Now, some of you may have been saying in the first one and in this one, but the variable was on the other side. It is okay. In an inequality statement, I can switch the two sides around as long as I keep everything the same. All signs have to go with them and everything else. So here we just divided both sides by 6. Right? We're not quite done yet, because the last thing I need to do is make sure this solution works back in the original equation. I got to check for extraneous solutions. So we got a solution of 27 over 2, or 13.5. So I've got 10 times, and then I need to go to math, go up to option A. There we go. Log base 3 of 6 times, and now I need to put in my value for m. That would be 27 divided by 2. Or you could go ahead and put in 13.5. Now, when I press enter, if I get 40, we're good to go. And we did. So that means 27 over 2 is not an extraneous solution. Now, in these, just like we saw in a previous lesson, if all I have is a single solution and my solution is extraneous, then my answer would just simply be no real solutions. All right, no real solutions, because in Math 4, we're only looking for real solutions. That's it. Now I'm going to have a follow-up video on how to solve the second type of equations. All right, so make sure you watch that one as well.